Hello, everyone, and thank you very much for attending this talk. So my name is Bushra Alahmadi, and I'm a cybersecurity researcher and consultant on AI and security. So my research falls at the intersection of security and AI. So I research the application of artificial intelligence and machine learning in the cybersecurity space and the challenges that we face within. And since the AI bubble started, cybersecurity domain recognized the potential in AI and started adopting artificial intelligence into cybersecurity products. And years later, we are now at a point where we can evaluate these products and determine its success in solving cybersecurity challenges. So I ask you, do you believe that AI-powered cybersecurity technologies are the real deal, or are they just snake oil? So in the next 20 minutes or so of this talk, I will go through the challenges that vendors and businesses are facing when it comes to AI-powered cybersecurity solutions and how we can go about developing even better and more reliable solutions. And before I start, let me give you a brief introduction to the nonprofit organization Hemaya, which I am a member in. So Hemaya is a nonprofit organization that is dedicated to serving the information security community in Saudi Arabia. So it's one of the leading cybersecurity associations in the country. It has over 500 cybersecurity specialists as members and specializes in providing cybersecurity training, awareness campaigns, and cybersecurity consultancy. And you can find more information about our organization at our website as well as Twitter. Well, let's start from the beginning. What did cause the AI bubble? And why now? Well, as you all know, AI is already driving everything from things many of us are used to, like recommendations engines, to really high-stake use cases, like autonomous vehicles. And that's all thanks to the advances in storage and compute and the research in AI algorithms, all which are necessary to build AI-powered products. And with the reinvention and popularity of AI today, came the burst of cybersecurity businesses that provide AI-powered cybersecurity solutions. So we've seen businesses in anti-fraud and identity management, behavioral analytics, anomaly detection, and the list goes on and on. So most cybersecurity products now have AI embedded in them one way or another. And with that came the high expectations that these products will completely solve cybersecurity challenges, that they will automate the workload that is causing analysts burnout and frustrations, and may be even able to automate not only the detection, but the response to cyber attacks. So companies buy AI products thinking that they are the magic wand that will finally solve cybersecurity challenges. And of course, when you have such high expectations and you don't meet these expectations, you get huge disappointments. So vendors that buy AI-powered products thinking they are plug and play, that they can immediately start working and catch those intrusions and malwares and even APTs will be disappointed. So in 2019, SANS did a survey on SOCs. So they did a survey with 500 respondents. And they found that the highest count of dissatisfaction that the respondents reported from all the tools that they use came from AI and machine learning tools. So specifically 53% of the respondents were dissatisfied with AI and ML solutions. And when they followed up with them with phone interviews, the respondents expressed their frustration with the hype around the effectiveness of machine learning in addressing some of the cybersecurity obstacles. That the illusion of monitor everything and big data or machine learning system will sort it all out are just smoke and mirrors, a way for companies to market their products. And well, of course, when marketing such AI-powered products that are capable of detecting cybersecurity threats with the sophistication and the mathematics of AI, of course you would end up with companies and analysts that would believe they are buying this, a very intelligent machine that is capable of replacing human analysts, the terminator of all cybersecurity solutions. When in reality, what they are buying is this, which, believe me, this is fine. I'm not saying that AI products are not useful. On the contrary, I do believe that AI in cybersecurity is revolutionizing how we monitor and detect and respond to threats. What I think we did poorly is communicating these products' capabilities and shortcomings to our customers, jumping on the wagon and using buzzwords like AI or intelligent to market these products. And of course, this is why our customers and the analysts that use such systems are frustrated. They expected something different. And one of the most used buzzwords currently is AI, right? But are they actually AI-powered solutions or snake oil? Is what you are buying really artificial intelligence? So you hear buzzwords like AI and machine learning or deep learning, which people often get mixed up. So people find it hard to differentiate between them. So what is AI or what is artificial intelligence? So AI is when you have a system that can learn a repetitive task and reason just like humans. While machine learning is a methods and a means to AI, but it's not AI by itself. So previously we had something called expert system, where an expert will go and teach the machine everything it knows about how to do a specific task. One of the famous examples for this is autopilots, and that's AI. But when we think of AI as humans, what comes to our mind is the movie's definition of AI, the Terminator robots. So with machine learning, we show that machines enough samples of a specific task, and after a while, this machine can start to learn that task and able to do it by itself. We have also deep learning, which is a subset of machine learning, and it uses specifically neural networks to learn from large amounts of data. So the answer to the question whether AI in cybersecurity, are we there yet? Spoiler alert, the answer is no. We have not reached the level of AI just yet. So most products that exist today are machine learning powered solutions. So the intention of machine learning is to enable machines to learn by themselves using the provided data and making accurate predictions, which is what most cybersecurity solutions are. But AI, of course, sounds better and is more marketable. But how can we reach there? How can we build better machine learning powered products so that one day we can reach that level of AI and automate tasks to the level where we will have machines replace an analyst, for example, in a SOC? So let's dig deeper to the process of machine learning. How can you build a machine learning powered engine? So with machine learning, you start with a use case. What do you like this model to do? And once you define what your use case is, you can start collecting the data you need. So you would probably need a huge data set of labeled samples that fit your use case. And once you have your data, you can start the feature engineering part. What does the threat you want to detect look like? And once you identify those features, you can then build and train your model and evaluating as you go and adjusting the model until you get a robust enough model that is ready for production. So of course, after that, you would need to keep an eye on this model in case the performance drops and just adjust the model accordingly. So really it's an iterative process. Simple, right? Well, not quite. So it turns out that it's not that straightforward. There are many challenges that we need to consider when we build machine learning powered solutions. So if you look at the problems in other well-established domains, such as image classification, they suffer from problems such as bias, performance, and how they perform testing, just to name a few. And cybersecurity also suffers from the same inherent problems, and even more. In addition to these problems, we face problems with data, feature engineering, and most importantly, that we are facing an adversary, a moving target, an unknown that we need to anticipate and prepare for. So let's talk about these challenges. The most important thing when we build ML models is the data. Do you have enough high quality and quantity data? And many times in the cybersecurity domain, this is a challenge. And if you're using customer data, they might be reluctant to share their data or might give it to you, but anonymize it to the point that it becomes unuseful. So you need to work out with what you have. And oftentimes it requires you to maintain the privacy of your customers and use machine learning powered products that are privacy preserving. We also have a problem with the lack of labeled samples and certainty in the ground truth. Not only do we need the data, we also need labeled data, which is an issue in cybersecurity. specifically, what does a cyber threat looks like? The answer to this question will differ based on the organization, of course. Also, we have problem with biased data, non-representative data, or a small data sets. So successful machine learning applications require large representative data set. So if your data set does not represent a certain use case you have in your organization, for example, a certain system or network usage, then that will result in a high number of false positives and false negatives. And also we have issue with missing data that is due to misconfigurations. So are your data resources reliable? Also, the art and creativity in machine learning is the feature engineering. What features will you use to build the machine learning model, and how is it represented? And as we said, this is one of the main challenges in security. What does a threat look like? And for that, what you need is domain experts or cybersecurity experts to help the data scientists. And it's one of the most time-consuming and error-prone steps of the process. So we need to take the raw data and figure out these domain-specific transformations that we need to do, which is very time-consuming. Another big challenge in security particular is adversaries changing tactics. So adversaries are a moving target, and to be able to detect threats using machine learning, you need to know what they look like. You need to know your enemy. For example, malware changes its behavior, producing hundreds of variants each year. So when doing feature engineering, you take that in mind to make sure your model is capable of detecting these new variants, so that you use features that are generalizable and your models can stand the test of time. And of course, when it comes to machine learning, one size does not fit all. We cannot create a machine learning product that is plug and play. Each organization is different, and they have different systems, different networks, and usage that requires us to build customized machine learning models that fit the organization's networks and system. So currently what we have machine learning products that produce high volume of false positives that overwhelm the analysts, and they start to tune it out. And as they say, once bitten, twice shy. So the prevalence of false positives have led analysts to lose their trust in the alarms that are produced by machine learning powered products, and they tend to ignore it. So we need to remember that these analysts are already overwhelmed with alarms and do not have the time or patience to tune out false positives. So how can we design better machine learning products that address the challenges that we discussed? So at my time at University of Oxford, we did a study to understand the challenges that SOCs currently have in terms of the technologies they use in general and machine learning in particular. And from this study, we drew some understanding of what we need to improve on existing machine learning tools so that we can be one day usable in a SOC setting. So we draw from this study some findings, which we will discuss briefly in the next slides. But feel free to contact me if you want to learn more about this study. So in a SOC setting, you would have huge amounts of data. For example, network traffic, endpoint logs, web proxy logs, sys logs, all kinds and forms of data is all collected and monitored through the SOC. So these data feed into technologies like SIMs and the occasional machine learning powered tools. And these tools will monitor the data. And what type of data that feeds into it depends on the product, of course, and the use case it was built for. But at the end, it will generate some kind of alarm or visualization to the analyst that will ingest this information and put the puzzle together and figure out what that alert means. So that's a very abstract description processes of a SOC, or for monitoring and detection at least. So how can we improve this? So we will talk about 3 improvements that, based on our study, will take machine learning tools to the next level. So let's talk about explainability in AI. So AI-driven systems are based on probability and uncertainty. So providing users of the AI system the right level of explanation is key to helping them understand how the system works. And once users have a clear mental model of the system's capability and limits, they can understand how and when to trust it to help accomplish their goals. So when you incorporate a machine learning feature to your security product, security analysts will need to make decisions based on the predictions of your model, right? So for example, if you're building an advanced persistent threat detection system that is powered by ML to detect APTs, it can alert analysts in a SOC, and based on that, they need to make a decision. So the analyst's decision on what action they should take, such as whether they should pull the plug on an APT, depends on how much they trust your ML product. And in our study of SOCs, we did find that analysts usually choose to start the investigations based on the alerts that were generated from tools that they trust and found reliable. So in short, explainability and trust are inherently linked. So let's talk about the trust spectrum. So on one hand, you risk having your users having no trust in your system. Say if they don't know where this prediction is coming from, so they'll just ignore it, which is unfortunately the situation we have now with some products. On the other hand, if the user assumes that the system always knows best and they don't question it, then you risk your users having too much trust. And because AI products are based on statistics and probability, the user actually shouldn't trust the system completely. So we need to help our users and analysts to calibrate their trust, so be in between. And based on the system explanations, the user should know when to trust the system's predictions and when they should apply their own judgment. And in a SOC or a security settings, we can't eliminate the human element and have full automation, or not just yet anyway. So humans are machines, and machines should work together, leveraging each other's strengths. So machines are good at providing faster than human analysis to identify leads to investigate, while humans or analysts are the hunters that provide the contextual understanding and use their cognitive abilities of pattern matching, reasoning, and even communication to investigate a threat. So some companies are starting to adopt such human-machine collaboration in the SOC. And through this collaboration, analysts can provide feedback on the machine's predictions and allowing them to improve over time until the model itself can self-learn and tune itself. The final point is that in order to develop machine learning powered solution in cybersecurity, you need to have both the data scientists and the cybersecurity experts throughout the model design, training, and testing. So the data scientists might know how to properly engineer an ML model, but they probably don't know what features they should use and what does a cybersecurity threat look like. So cybersecurity experts help identify those cybersecurity use cases and work together with the data scientists to engineer features and build the models. And of course, this is an iterative process. And as we mentioned, we need to understand how the machine learning based feature really impacts users and how they interact with it, and not just focus on the design of the model or what's happening in the model layers. So we work with UI designers to design visualizations that not only show predictions, but also provide the right level of explainability. So that's one aspect of what we mean when we say usually human-centered AI, especially given the general public's misconception around what AI even is. So as you see from this talk, when discussing AI and cybersecurity, we are not there yet. But it's a journey. It's a journey that starts with machine learning and addressing its challenges to build better solutions. And with building better solutions, we can build again the trust relationship between analysts and machine learning products once again. So we need to provide explainability to the alarms and have analysts calibrate their trust accordingly. We need to adopt a human machine learning collaborative model, leveraging each other's strength. We need to build customizable model, incorporating context into the models. And of course, we need to have both domain experts and data scientists work together to engineer features and build models with robust features. So these are some of the recommendations that can help us build good ML solutions so that one day we might actually be able to really develop AI-powered solutions. And before I leave you, here are just some takeaways for customers that are looking to adopt machine learning powered security solutions. Don't fall to the smoke and mirrors. Ask about the algorithms behind the products. Do they meet your security needs? How long does it need to train? And how frequent does it need to be retrained? Do your homework. Adopt a layered approach. So machine learning alone or machine learning products cannot detect and stop a cyber attack. What we need is a holistic approach that has a mix of technologies to detect both known and unknown attacks. Don't rely on technology alone and leverage human-machine collaboration. Look for solutions that explain their predictions. Not only should insights be accurate, but they also need to be actionable. So security operators need to know why a detection occurred to determine the action, and a black box model cannot provide that. And most importantly, not all problems can be solved with AI. Some problems are actually simple and can be solved with simple statistical models. So don't use a sledgehammer to crack a nut. And with that, I conclude my talk. Here's my contact details, and feel free to contact me with any follow-up questions. And thank you again for attending.